Welcome to your Algebra 2 Capstone Lesson 2. We're going to talk about the arithmetic of algebraic expressions. And so remember, terms are simply either numbers or products of numbers and variable expressions. Polynomials are the sums of one or more monomials, one or more terms. The one thing is you have to have integer powers of your variables and you can't divide by a variable. If you have, in fact, they have to be positive integer powers of your variables, because if you have negative integer powers, that's just hiding dividing by the variables, because x to the negative 1 is 1 over x. So that makes it not a polynomial. Square roots makes it not a polynomial. And again, if it's in the denominator, not a polynomial. And we want our polynomials in standard form, which means we want them in decreasing degree, or another way to say that is descending powers of your variable. All right, so for example 1, we're going to write the polynomial in descending powers of the variable. Same thing as decreasing degree, just descending powers is a different way to say that. So we're going to take our polynomial here, our negative 3y to the 4th minus 6y plus 2y cubed plus y to the 5th, and we are going to reorder it to standard form, and so that'll give us y to the 5th minus 3y to the 4th plus 2y cubed minus 6y. Okay, remember if you just have one term, the degree is going to be the exponent of the variable. If you have more than one variable in that term, it's going to be the sum of the exponents of the variables. And if you've got a polynomial, the degree of the polynomial is going to be the same as the greatest degree of any of the terms. So you just find the degree of all the terms, and the biggest degree there gives you the degree of the polynomial. Most numbers have a degree of 0, except for 0. It has no degree. So it just has no degree. All right. Like terms of a polynomial have the same variables raised to the same powers, and you can add them together. So we're going to combine like terms here. So you need to make sure you have the same variable and the same power. So we've got 2z to the 4th plus 3x to the 4th plus z to the 4th minus 9x to the 4th. So our z to the 4th terms are like terms, and our x to the 4th terms are like terms. Now, because we have terms that have x's in them and then terms that have z's in them, we usually put the variable that comes first in the alphabet first. So I'm going to do 3x to the 4th minus 9x to the 4th is negative 6x to the 4th, and then I'm going to look at 2z to the 4th plus z to the 4th is 3z to the 4th. Okay, I've got 3t plus 4r minus 4t minus 8r, so yep, the r's are going to be combined together and the t's are going to be combined together. So 4r minus 8r is negative 4r. 3t minus 4t is minus 1t, or just minus t. Now, on this one, we've got products of powers of two different variables. We've got x's and z's in the same term, so we're going to have to be a little more careful. If you look, we've got 2x squared z terms, and we have 2x cubed z squared terms. Let's see, the x cubed z squared term should probably come first, so let's go ahead and combine those. Negative 3x cubed z squared plus 12x cubed z squared is 9x cubed z squared. And then 5x squared z plus 8x squared z is 13x squared z. All right, let's add some polynomials. When you are adding two polynomials and they're separated by parentheses, it's really easy. You just drop the parentheses and combine like terms. So we've got negative 5p cubed plus 6p squared plus 8p cubed minus 12p squared. So let's combine our terms. Negative 5 plus 8 is 3, so we have 3p cubed. 6p squared minus 12p squared gives me negative 6p squared. So I end up with a final answer of 3p cubed minus 6p squared. All right, 3b is a problem to try on your own, so go ahead. It's a good idea to pause the video and go ahead and do this now, and then come back and we'll keep going. All right, so now we're going to subtract. Remember, if you are subtracting one polynomial from the other, the first polynomial is still easy, you just drop the parentheses, but for the second polynomial, you have to remember that you're subtracting everything. So if you're going to drop the parentheses, you have to distribute that minus across every term there. So we'll have the minus here with the 3p to the fourth, and then minus 5p cubed, and then minus 2. So let's combine terms. P to the fourth minus 3p to the fourth is negative 2p to the fourth. P to the third minus 5p to the third is negative 4p to the third. 5 minus 2 is 3. All right, example 4, part B is also a problem to try on your own, so go ahead and pause the video and do that, and then come back. All right, when we are multiplying terms, we have to be careful that we multiply the coefficients together. And so 3 times 5 is 15, and then the variable portions of our terms, we multiply those together by adding the exponent. So x to the fourth times x cubed is x to the seventh. All right, so we're going to multiply 8x cubed times 9xy cubed. I think I said 8x cubed y times 9xy cubed. So we're going to have 72, because 8 times 9 is 72. And then x cubed times x is x to the fourth, and y times y cubed is y to the fourth. All right, remember for distributing, if you have something like this negative 3 outside parentheses, and it's right next to it, and you've got x to the fourth minus 7, that means to multiply, and so we need to distribute, and so you're going to multiply the negative 3 by both of those terms, and so you'll end up with negative 3x to the fourth plus 21. If you have a binomial times a binomial, you do the repeated distributive property, so you take the 2x and you distribute it through that second binomial, and you take the y and you distribute it through that second binomial. Or since this is a binomial times a binomial, you can do FOIL, where you do your first two terms, your outside two terms, inside two terms, and your last two terms. You do those little products, and then you combine like terms, and you are done. So, for example 6, for part A, let's multiply negative 2r times 9r minus 5. So we're going to distribute to get negative 18r squared plus 10r. For part B, we're going to FOIL with 2k minus 5m times 3k plus 2m. So we're going to get 6k squared plus 4km minus 5 times 3 is 15km minus 10m squared. Now, the middle two terms can be combined, and we have 6k squared minus 11km minus 10m squared. All right, for part C, that's another binomial times a binomial, so you'll FOIL there, and so we're going to leave that as a problem to try on your own. So go ahead and stop the video and do that now, and then come back. For part D, we have a polynomial times a binomial, but it has more terms than a binomial, so we're going to do the repeated distributive property. We don't have a cool way to remember it like FOIL. We're just going to have to think it through. So we're going to take the 5a cubed, and we're going to distribute it through the 2a minus 5, and that's going to give us 10a to the fourth minus 25a cubed. Then we're going to do the same thing with negative 6a squared. When we multiply by 2a, we get negative 12a cubed. When we multiply by negative 5, we get plus 30a squared. Now we're going to distribute the 2a, so we'll get 4a squared minus 10a, and now we'll distribute the negative 3. So negative 3 times 2a gives me negative 6a, negative 3 times negative 5 gives me 15. And at this point, we combine like terms. So we've got 10a to the fourth, because that's the only a to the fourth term, negative 25a cubed minus 12a cubed gives us negative 37a cubed, 30a squared plus 4a squared gives us 34a squared, negative 10a minus 6a gives us negative 16a, and then plus 15. And we are done. All right, there are some special multiplying patterns that you must know. We usually think of difference of two squares as a factoring pattern, but it works just as well as a multiplying pattern. If you see x plus y times x minus y, that multiplies to be x squared minus y squared. You can also think of this as the conjugate pattern, because when you multiply conjugates together, the middle terms always cancel. The perfect square trinomials, x plus y quantity squared is equal to x squared plus 2xy plus y squared. And I have a little memory device for that, and along with the other one where you have a minus, the x minus y quantity squared equals x squared minus 2xy plus y squared. let's see, a friend of mine taught me this, a teacher friend. You square the first, so x squared, square the last, so y squared, double the middle, so 2xy, and get out fast. Okay, so perfect square trinomial, square the first, square the last, double the middle, and get out fast. So that's the way to remember that. All right, the cube of a sum, so x plus y, the whole thing cubed, so x plus y times x plus y times x plus y multiplies to be x cubed plus 3x squared y plus 3xy squared plus y cubed. X minus y, the whole thing cubed, is equal to x cubed minus 3x squared y plus 3xy squared minus y cubed. Okay, so I don't have like a special memory device for this one, but I want to point out a couple of things. You start and end with x cubed and y cubed. Well, that kind of makes sense. And then if you look in the middle, right here, you've got the 3x squared y, 3x squared y, or xy squared. You have both possibilities where the degree is 3. See how this is third degree, this is third degree, this is third degree? Well, so are these. You have x squared, y to the first, and you have x to the first, y squared. Okay, that's true always. And you go in decreasing degree of x. You've got x cubed, x squared, plain x, no x at all. And same thing down here. You've got x cubed, x squared, x, no x at all. And on here, your signs just go back and forth. You start off with positive x cubed, and then you have a minus, and then a plus, and then a minus. So hopefully that will help you memorize them. You need to know these. All right, m plus 5 times m minus 5. Well, that's going to be m squared minus 5 squared. So m squared minus 25. I'm going to let you do x minus 4y times x plus 4y as a problem to try on your own. So go ahead and stop and do that, and then come back. Okay. Here we've got 4y squared times y plus 7 times y minus 7. Well, we've got a conjugate pair there. We've got the difference of two squares there, so that's going to be y squared minus 49. And now distribute the 4y squared. So we have 4y to the fourth minus 196y squared. Okay. X plus 9 squared. So we need to square the first, square the last, double the middle, so 2 times x times 9, and we get out fast. So x squared plus 18x plus 81. Okay, try the next one on your own. All right, let's do 3k minus 2n quantity squared. Okay, so we're going to square the first, so 3k squared, square the last, so way at the end put plus, and then put parentheses 2n squared because you want to square the whole thing, double the middle. We copy our minus sign down, and we put our double, and the middle is going to be 3k times 2n, and then we're going to get out fast. First, we're going to simplify. So 3k squared, 3 squared is 9, k squared, minus 2 times 3 is 6, times 2 is 12, kn, and then plus 2 squared is 4, and then n squared. All right, we've got x minus 2y cubed. So let's see, that's going to be x cubed minus, okay, because the signs are going to go back and forth, minus 3 x squared 2y to the first power, just plain 2y there, plus, because the signs go back and forth, 3, because that's part of the pattern, times just x to the first, or just x, times 2y squared. Then we look back and go, that one was a plus, so this one's a minus, 2y cubed. And then we simplify. X cubed minus, let's see, that's 6x squared y. Let's see, we need to square this, so that's 4y squared, and we'll have to simplify one more step here. And then minus 2 cubed is 8 times y cubed. We still need to do our 3x times 4y squared, and so that gives us 12xy squared. And we are done because we don't have any like terms. So we are done multiplying. All right, notice this pattern here. In the brackets, we've got 3x minus 2 plus 5y times 3x minus 2 minus 5y. Those are conjugates. So we can use the difference of two squares and do the first term, if you consider 3x minus 2 as one big parenthesis term, squared, minus 5y, so it's really the first expression, squared, minus the second expression, squared. So I have to FOIL that, so I'm going to get 9x squared minus 12y plus 12x, plus 4, minus 5 squared is 25, y squared is y squared. So if we have something like x minus y plus z times x minus y minus z, we can do x minus y squared minus z squared, because they are conjugates where your first expression is x minus y and your second expression is z. So we just FOIL out the x minus y squared. Actually, it's a perfect square trinomial. So you square the first, square the last, double the middle. So it's a minus, so you write down minus and then double xy and get out fast. And do the minus z squared. And let's see, there's nothing to simplify and there's no like terms, so we are done. I'm going to let you do p plus 2k to the third power on your own. Okay, x plus 2 to the fourth. We're going to write this as x plus 2 times x plus 2 to the third because we have a special pattern for binomials to the third power, and then we'll take that special pattern product and we'll multiply it by x plus 2, and that'll keep us from having to do x plus 2 times x plus 2 times x plus 2 times x plus 2. Alright, so let's apply that power, that cube, binomial cubed pattern here. So I'm going to write down this x plus 2, and then I'm going to have x cubed plus 3 times x squared times 2 plus 3 times x times 2 squared plus 2 cubed. You're going to have to simplify there a little. So I'm going to have x plus 2 times x cubed plus 6x squared. 2 squared is 4 times 3 is 12, so plus 12x plus 2 to the third is 8. Now, I don't have a special pattern for this. I'm just going to have to do the repeated distributive property. So let's see. I'm going to get x to the fourth plus 6x cubed plus 12x squared plus 8x. Come back and distribute the 2, so plus 2x cubed plus 12x squared plus 24x plus 16. And I'm going to combine like terms. I only have one x to the fourth term, so that was easy. 6x cubed plus 2x cubed is 8x cubed. 12x squared plus 12x squared is 24x squared. 8x plus 24x is 32x, and then plus 16. Whew, and we're done with that. And that is it for this lesson, and you've already done the problems to try on your own. Thank you so much for taking good notes and watching the video. I hope you have a great day, and I will see you in class.